Welcome to the Unit 1, Section 4 video on applications of equations. Now that we have gone over how to solve equations, it's important to be able to apply this to real-world situations. So recall, there are several keywords that indicate that a particular operation is being used. For addition, we have several phrases such as added to and plus. Subtraction, you have difference, taken away, taken from. For multiplication, you have multiplied by, groups of. In division, you have divided into, the ratio of. Just for example, you can see more of those here in this table. And of course, there are more than just the ones listed here. But it's important to be able to recognize what operation is happening when you read a word problem. To solve a real-world word problem, you're going to look for keywords that indicate the operations being performed. Then, you're going to identify the variable. What are you trying to solve for? This is usually posed as the question in your word problem. Write the equation that models the situation, then solve the problem. Finally, you're going to express your answer with units within the context of the problem. A word problem requires a word answer. It doesn't have to be incredibly long, but it needs to be enough to put the value of the solution into context so you know what it means. So let's do a few examples. You and your 4 friends go to Grumpy Monk. You split the bill equally. Each person owed $13.75. That includes tax and tip. How much was the bill including the tax and the tip? So we want to find out what the total bill is. That's our variable. Now we're going to model this. If each person owed $13.75, we had 4 people eating together. We know that we split the bill 4 ways. So that total bill was divided by 4 to get $13.75 per person. Now we're going to multiply each side by 4 to get the variable by itself, and that gives us $55 as our total bill. And that's essentially how we write the solution. The total bill was $55. You notice this isn't a very long sentence. It doesn't have to be, just enough to tell us what the context of the solution is. For example 2, Carolina Forest High School has 2,430 students. Carolina Forest High School has 850 more students than Myrtle Beach High School. How many students are at Myrtle Beach High School? So that's our variable. The number of students at Myrtle Beach High School is what we're trying to find. Well, we know that there's 850 more at Carolina Forest than at Myrtle Beach High School. So you have to take the number of students at Myrtle Beach High School, which is X, and you have to add 850 to get the total that are at Carolina Forest High School. Now we're going to subtract 850 from each side to get the number that are at Myrtle Beach High School. So now that we have that number, we can write our solution. There are 1,580 students at Myrtle Beach High School. And notice here, it's not enough to just say there are 1,580 students. If you just say that, we don't know. At Carolina Forest High School, at Myrtle Beach High School, at some other school, you have to state what school you're talking about. For example 3, Mary rents a car for a day. The charge is $18 and 12 cents per mile. She wants to spend exactly $30. How many miles can she drive? Well, we want to know how many miles she can drive, so that's our variable. It costs 12 cents per mile, so we're going to be multiplying 0.12 times x to get the number of miles. And then we also have to add the 18 to it to get our total price. And that total price needs to be 30 because that's how much we want to spend. So now we subtract 18 from each side, and then we divide each side by 0.12 to get our final answer of 100. So our solution is Mary can drive 100 miles. In example 4, a company buys paper by the case. They bought 45 cases. If the paper had been $2 a case less, they could have bought 5 more cases. how much does one case of paper cost? So we know that the price of 45 cases is the same as 50 cases if it had been $2 less per case. So our variable here is how much does one case cost? So our equation is going to be 45x equals 50 times x minus 2. Okay, 45 cases cost the same as 50 if the price were $2 less, and that's our x minus 2. So here we're going to distribute our 50, and we're going to subtract 50 from each side to get our variable on the one side. And then we're going to divide each side by -5 to give us 20. So our answer is the company paid $20 per case of paper. Now, when checking the solution you get to a real-world problem, it can be helpful to think about if the value that you get is reasonable for the context that you're given. So if it's not reasonable, then it's not likely to be correct. So let's take a look at examples of what this would look like. So we're going to determine if each solution is reasonable or not reasonable within the given context. So for A, the price of a cheeseburger is $4.99. Is that a reasonable amount for a cheeseburger? Well, yes, $4.99 is within the range of prices that you would expect to pay for a cheeseburger, depending on where you go and all sorts of things like that. So it is reasonable, so it could very well be a solution. For B, a person runs at a rate of 32 miles per hour. Well, think about how fast 32 miles per hour is. It doesn't seem feasible that a person would be able to run that fast. Okay, so therefore it's not reasonable, and if you get that for a solution within that context, chances are your solution is incorrect. For C, a pizza restaurant sells around 375 pizzas per night. Well, that could be reasonable. That's a lot of pizzas, but if you're talking about maybe a chain restaurant, it's possible. All right, 3 more examples here. About 9 gallons of water are used for a shower. Well, if you think about, you use maybe a gallon a minute, and you're in the shower for about 10 minutes, that's about reasonable. A ticket to the Super Bowl costs $10.75. Well, the Super Bowl is probably the biggest game of the year in the NFL and possibly in all of football. So that those tickets are going to cost a lot more than $10.75. Even the bad seats are going to cost a lot more. So that is not a reasonable value for a solution. And for F, a person can type 5,432 words per minute. There is no way a person can write or type that many words per minute, even if they are typing just the word A over and over and over for a minute. There is no way they can get to over 5,000 words per minute. So that is not a reasonable value for that type of solution. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.